Hello, my dear students. Here we are having very interesting concept and question again, and this is question of related to the capacitance. Okay, and in this question, each of plate is shown in figure. Okay, has surface area 96 by epsilon naught into 10 raised to power minus 12 on the one side. Okay, the separation between the successive plate is 4 centimeter. The EMF of battery connected is 10 volt. Find the magnitude of charge supply by the battery to each plate of the connected to it. Okay. So here this battery, the positive terminal of battery we are connecting to this plate. Let us consider this plate is A, this is B, this is C, and this is D. So we are having 4 plates. So if we are connecting positive terminal to this battery, definitely positive charge will induce here. Okay, let us consider Q charge is inducing. Same amount of negative charge also induce on the opposite plate, that is the B. But if this plate is isolated, there is no source of charge here. So the same amount of positive charge will also develop on the opposite face. Okay, and here if the positive charge are there, definitely C, the front face of C will have the negative charge, and from where this negative charge is coming, from the negative terminal of the battery. Okay, so if this battery is connecting, we are connecting to the negative terminal, this C is connecting to the negative terminal, so this on both side we can consider the negative charge. Okay, and here in front of this negative charge, positive charge will be there. Okay, so what we can do, we can redraw this structure. Okay, and always whenever this type of intermediate plates are coming, you have to consider this plate as two plates having two surface. Okay, so this plate number 1, that is A, and the plate number B. Okay, so it will form one capacitance. Let us consider it is C1. Now this plate number B, okay, having the opposite phase of negative charge. Okay, as shown in figure also. Okay, it is in front of the plate C, and the opposite side of plate C we are considering here. Okay, having the negative charges. Okay, and here is the positive charges, as already we have explained here. This A plate will have positive charge because it is connecting to the positive terminal of battery, and the front face B will have the negative charge. Okay, sorry, here the positive charge are there on the opposite face of B, and the negative charge here because it is connecting to the battery, and we are connecting battery in between this B, in between this A and C. Okay, so let us consider now this B and C will become one capacitor, and we are considering it is C2. Okay, now in front of the negative face, the opposite face of C, there is one plate D is there, and this D we are directly connecting to the B, so we are connecting this D plate to the B. Okay, and it is isolated, so we can consider here positive charge. Okay, so this type of structure now coming in front of us, and we can redraw this structure using the capacitance. Let us consider it is C1, and again it is C2, and with parallel, because this terminal and this terminal directly connected, so this C3 we can consider parallel to the C2. Okay, parallel to the C2, and in between these two terminal, okay, battery is connecting, we are connecting the battery. Now if we are finding all this C1, C2, C3, it is C3 will have same capacitance because area of cross section and distance is same, so all having capacitance C. Okay, so what will be the equivalent capacitance? This C and C will become, these are two in parallel, so it will become 2C, and this 2C and C will be in series. So C equivalent will be C into 2C divided by C plus 2C, and it will be 2C by 3. So what should be the charge? This Q equal to C equivalent into V. That is the charge delivered by the battery. And the C equivalent is 2C by 3 into V. And what should be the value of this C? This value of C should be epsilon naught A divided by D. And value of V, that is equal to 10. Okay. And the value of this area of cross section is given here. So this 2 by 3 is as it is, this epsilon naught also as it is, and if you are just placing the value of this epsilon, this area of cross section, that is 96 divided by epsilon naught into 10 raised to power minus 12 divided by D, and what is value of D? That is 4 mm, so 4 into 10 raised to power minus 3 to convert into meter, and the value of V as it is we are taking 10. So this epsilon naught will cancel out, this 2 and 4 will cancel out 2 times, and this 3, 96 will cancel out 32 times, and this 2 will cancel this 32 by 16 times, so it will become 16 into 10 raised to power minus 12, and this minus 3 coming to the numerator will become plus 3, and 10 is there, so it will become plus 4, so minus 12 plus 4 will become minus 8. So you can write that it is 0.16 into 10 raised to power minus 6. So it is 0.16 microcoulomb, and that is the answer. That is the charge delivered by the battery. Okay, thank you very much.